Hello, we're going to do an example of vertical dynamics. The example reads, an elevator with a mass of 900 kilograms is accelerating downward at a rate of 1.30 meters per second squared. What is the tension in the cable? Well, our first step is always to list our knowns. So we have our mass, and that's equal to 900 kilograms. We have our acceleration due to gravity, our acceleration of the object. Because it's downward, it's negative 1.30 meters per second squared. We have our acceleration due to gravity. Now that's not explicitly given in the question, but anytime you're dealing with vertical dynamics, we need to deal with the force of gravity. So we have the acceleration due to gravity, negative 9.81 meters per second squared, and we're looking for the tension. Once we've listed our knowns, our next step is to do our free body diagram. So we come over here, we'll do our free body diagram. We have our elevator with the center of mass marked. We draw an arrow downward to represent the force of gravity and an arrow upwards to represent the tension holding the cable up. So our net force is going to be the sum of those two forces. Force net is equal to the tension plus the force of gravity. Now, we're looking for the tension. We don't have the net force or the force of gravity, but we can calculate those. And so we take and calculate the net force. Remember, net force comes from Newton's second law. That's mass times acceleration due to gravity. Our mass is 9,000 kilograms times the acceleration of the object, which is negative 1.30 meters per second squared. And that gives us a net force of negative 1,170 newtons. So now we have our net force. We just need to find our force of gravity. And again, we can calculate our force of gravity. For the force of gravity is equal to the mass times the acceleration due to gravity. So we have 9,000 kilograms times negative 9.81 meters per second squared, and that's equal to 8,829 newtons. Oh, and that should be negative 8,829 newtons. It's negative because the force of gravity is acting downwards. So we can substitute in now to our net force equation. We have negative 1,170 newtons. That's equal to the tension, which we're looking for, plus the force of gravity, which is negative 8,829 newtons. To solve for tension, we simply add 8,829 newtons to both sides. And that gives us a tension of positive 7,659 newtons. It's positive. That means that the tension is acting upwards. So our algebra, our math, matches what we know to be true. We know it needs to be acting upwards. And so now we can write this to three significant digits, which the question is in. So that's 7.66 times 10 to the 3 newtons, and it's acting upwards. Thanks for listening. Bye for now.